Good morning, judges. Welcome to our verbal presentation. My name is Sam Abdul Latif, and I'm the mechanical engineer for this esteemed project. I have a background in suspension, and I've worked on the suspension design and tuning for this project.
My name is Mahir Masihuddin, and I am the CAD and electronics engineer of Matrix. I have worked on the CAD design for various things, from the car shell that has been made out of cardboard to various 3D printed parts you can find inside our car. I have also worked on the electronics, such as the circuit that powers most of our electronical aspects of the car.
I am Sai Satvik Godina. I am the visual effects and software engineer for this team. I have designed and coded the electronics as well as the presentations and portfolios for this project. Now let's talk team identity. Our team, the Off Matrix, symbolizes defying our limits. We go beyond boundaries and we explore them. We are comfortable with going to the unknown. We keep learning and exploring. Now, as you can see in our logo, it signifies that we are breaking through the barrier, the matrix.
Now on to tow bar design, our first innovation. Initially, we started with the design provided by Yasin Schools, which attaches directly to the rear axle and uses a rack and pinion mechanism that is 3D printed. This design features a rather small rack and pinion mechanism, meaning it is prone to jamming and can be destroyed easily. Hence, we developed our first prototype, the initial prototype. This shows a larger pinion and rack mechanism that is also 3D printed, hence it is easily reproducible and we can test it and its mechanical properties.
Now, the final mechanism has been tested by me. This mechanism takes the pros from all of the rack and pinion mechanisms with none of the cons. This was a learning opportunity for all of us on the shear and torsion stress on the plastics that we are using. Now, on the sustainable body, we call Mahir.
Now, speaking about our light and sustainable car body, I designed this car body in Fusion 360 using CAD modeling. I started by sketching out a shell. It was then designed in Fusion 360 and then exported and unfolded using a software called Pepecura Designer. We then laid this out on cardboard and cut out our shell. Here you can see our final product. This is the car shell made out of cardboard. It is light and sustainable. We researched many other ways to make our car body, but none of them were as light and sustainable as cardboard.
Now, let's talk about our primary innovation, dynamic body and lift control, or DBLC for short. It's where the body mounts have servos on them to adjust the height of the body mounts. The primary reason was for body roll and additional suspension droop. It helps in variable geometry in high-speed scenarios.
Let's speak of electronics and code. I am well versed in Python, but MicroPython has been a new learning experience for me. MicroPython, despite being similar to Python, includes pin ins and pin outs, which means that I'll have to configure the electronics to the code.
Now, coming to the electronics and circuit design, we started by laying out our components on a PCB and checking the size of what breadboard we need. We decided to go with a PCB instead of breadboards because these are more robust and we can easily replace components that have been damaged during the competition. Now, this was a new learning experience for me as well. Even though I am well versed in electronics projects, this was the first time I had taken on such a complex project. This involved hours of soldering, and I had to use a lot of schematics as outlined in the code made by Sai. We also decided to go with a brushless motor to power our car's drive system. This brushless motor replaces the brushed motor that originally came with it. The brushless motor is a lot more efficient at around 50% throttle, and it also provides a linear response and does not need as much maintenance as a brushed motor.
Now, here's one of our primary features. Four-wheel steering, where the front and the rear axle spin in different directions to reduce the turning circle in tight off-road scenarios. It helps us not have to take three-point turns where time is lost, and most importantly, it's a very difficult way to drive the vehicle. We have the crab walk mode, where the front and rear axle rotate in the same direction. This allows us to change the position of the car on the track without rotating the vehicle. This allows for easier driving of the vehicle while also maintaining the speed at which you're moving on. Now, let's talk about the project management. Despite ongoing challenges, we were able to complete the entire project within the given time frame. Various tasks like team name, logo design, initial code, electronics, etc., we were able to finish it within the 1 to 40 week period. Now on to Mahir towards a little bit more detailed explanation on this.
In order to manage our time and resources effectively, we researched various methods for time management. In the end, we settled on a Gantt chart, as displayed here. Here we have tasks, the start week and end week highlighted, from the start to the end of the project. We have various tasks listed, such as team name, logo design, prototyping, and portfolio design. Here we have different colored boxes that show how long each aspect of the project is supposed to take. As you can see, team name should take a maximum of 2 weeks, and so on. This helps us manage our time effectively.
Now on to finances.
Let's talk finances. We had a specific budget in mind, and most of that budget was spent in the high prices of electronics. Majority of our cost has been spent in electronics and sensors, followed by uniform and team merchandise. The other costs include DBLC prototyping, car manufacturing, and hardware repairs, while we also kept a little bit of space for miscellaneous costs. Now, all of this was possible only by Lunity AI. Lunity AI is a virtual assistant that helps students and other professionals to manage their tasks. It's a personal assistant, and it helps us to manage tasks, and it reminds us the tasks that we have, and it gives us the priority order. Any task that I want to do right now, it tells me the most important task that I should be focusing on.
Thank you for listening to our verbal presentation.